Yes.
Oh, it's looking at the wrong.
All right, so
I did the same thing.
yeah, so the graph should be easy enough for these kind of problems because it's really just making sure that what you have here is consistent with the units on the y-axis, and then after that it's just multiplication. But then we get the reservoir originally contains 8,250 gallons of water. How much would it contain after 5 hours? So we know it's well, we're pumping out.
Oh, like
Right.
taking out, so subtraction.
Right, so we're taking the 8,250 and knocking off 1,250. So that's going to get us to 7,000 gallons. All right, engineers want to turn off the pumps when the reservoir reaches a level of 2,000 gallons. Will they need to turn the pumps off during this 12-hour period? Show evidence to support your answer.
Oh, so you do 8,000.
Oh, you're yes, no.
8,250.
No, this 12-hour period.
8,250 minus 5,450.
Boom. 8,250. We know that we're going to lose 5,450 over that period of time. So if we subtract and we get something less than or equal to 2,000, then we could say that they would need to shut it off. But it doesn't look like that's the case, right?
2,800.
2,800 even. So we'd have to go beyond the 12-hour period to pump out and have a total of 2,000 gallons remaining. Assuming engineers do not turn off any pumps, how many total hours will it take to the nearest tenth of an hour to drain the reservoir of all of its water? All right, well, that's a different story. So you could go after this a couple of different ways, but I think the way that makes the most sense is to say that after 12 hours, we have 2,800 gallons. If we want to subtract, we're subtracting at a rate of 600 gallons per hour. So we'll take 600 gallons per hour and multiply it by the number of hours. I'll call that T for time. And then set that equal to 0, right? Because this is going to give us the amount removed after time T. This is the amount remaining.
It's 600 gallons per hour after 5 hours.
Right, yeah, because we're living in this piece.
And it's only for... Wait, but if it stops before 12, do you just have to assume that after 12 hours you keep it at 600?
Yeah, we'll keep it at that rate, yeah. Unless they tell us otherwise. From the previous answer, it comes from the idea that we started off with 8,250 gallons, and after 12 hours, we've removed 5,450 gallons, so that leaves us with 2,800 gallons in the tank. That's what's left, yeah. So then for part E, we're starting off with what's left following the same rate. Yeah, so it's 600 T equals 2,800.
Negative. No. Yes. Negative.
Yeah, but I made it positive 600 T. So I actually just moved this over and kept both sides positive. It's a savvy math teacher move. All right, so 14 thirds. So 4 and 2 thirds.
2/3 of 60. 4 hours and
To the nearest tenth of an hour, so 4 hours and 40 minutes.
yeah. Wait, could you do it without could you do it by subtracting? If you just subtracted 600 would have be the same.
Subtract.
Oh, but if you subtracted, so if
You talk about subtracting.
yeah, subtract 28.
Yeah, but then you divide by negative 600. The two negatives go to positive
It
anyway.
says 16 and 2/3 hours.
Oh, so then I have to. How many total hours? So then I add that on to the 12 hours that already happened. And you get 16 hours and 40 minutes. Which is the same thing. Good catch.